Green energy advocates have high hopes for solar and wind power. But Japanese researchers are pioneering something different. They've set up in Okinawa the world's only plant for ocean thermal energy conversion, or OTEC. They're making electricity from seawater.
Kumejima Island is 1,600 kilometers southwest of Tokyo in Okinawa Prefecture. It's surrounded by deep blue sea. In late March, prefectural officials funded an OTEC experiment there. The raw materials are surface seawater that's been heated by the sun and cold deep ocean water that's been pumped from a depth of 600 meters. The system works by using warm surface water to heat up a liquid chemical called an alternative chlorofluorocarbon that has a low boiling point. This generates steam to power a turbine. Deep seawater then cools the chemical back into a liquid. It can be used all over again.
The deep water is 9.2 degrees Celsius, the surface water 28.8 degrees. According to our simulation, it should generate 10.7 kilowatts of electricity.
In fact, the experiment went better than expected. It generated 12 kilowatts. The good result was due to the high efficiency of a device called a heat exchanger, which transfers heat from the seawater to the chemical. A venture capital firm called Zenesis is engaged in the research and development of OTEC. It's been developing heat exchangers for more than a decade. Heat exchangers have many layers of plates. They work by sending the seawater and the liquid chemical into alternating gaps between the plates. The biggest challenge until now has been how to use seawater to boil the chemical efficiently.
It's a corporate secret, so I can't show you from the front, but you can see it from the side.
The ribs on the plate hold the key to its high heat conductivity. When liquid flows onto the plate, the ribs obstruct the flow and create a whirlpool. This means more fluid touches the plate so it can heat up quickly. Zenesis has experimented with more than 50 types of plate designs.
The technology we've developed could provide electricity to about 20,000 households on a remote island. I believe we've come up with the optimum plate.
A major steel maker, Kobe Steel, produced the material for the new plate. It's made of titanium, which is resistant to rust even when exposed to seawater. On its surface are tiny bumps. This is a boiling experiment. On the right is the newly developed material. The conventional material generates larger but fewer bubbles. They rise slowly. The new one generates many small bubbles, which rise faster. The new plates conduct heat about 20% more efficiently than the older ones. Researchers at Saga University have been studying OTEC for more than 40 years. One expert says the recent successful experiment has taken the technology to the next stage.
The time has passed when all we could do was talk about our visions. New power plants are being developed all over the world, and the Kumejima Island project has given us a head start.
Large-scale OTEC projects are also being planned in Hawaii and Tahiti, but researchers in Japan have proven they can use the technology to get strong results. Supporters of alternative energy will be keeping a close watch on where they go from here.